Hi, I'm Ferhat. Ted Sander and I work in Google Ads. Specifically, we work on front-end infrastructure. Um, and about 2 years ago, I got the opportunity to join one of the first large-scale projects to use Dart at Google. And the project was basically updating an existing CRM system, a customer relationship management system. And our goal was to change the backend in flight, basically update all of our backend systems, our RPC layers, and at the same time solve some of the issues we were seeing on the front end. So some of the hints that an existing system needs updating is suddenly the application starts looking dated. It's teams, very large teams, are under high sort of pressure to deliver changes inside the application, and you sort of see that the visuals start suffering first. Today, all of us have a very high bar to meet in terms of making our UIs pixel perfect, having very good UX, very good user flows, and delivering very polished interfaces. So the existing app was definitely suffering on that side. Also, it started showing performance issues inside the application. And it just didn't have, the team just didn't have enough productivity to keep up with the changes that were happening in our business. So for the CRM system, it was pretty much from the ground up rebuild. And Ted started working on a project about the same time, too. What was your experience like, Ted?
Yeah, my story's a little different. I didn't get to start from a brand new project and kind of start from the ground up. I had this frustration coming to work every day, right? And I'm sure many of you have the same experience. Things were taking too long to see a change in our system. When we'd make a change, it would take 10 to 15 minutes before we could actually see that change on our local environment. You just didn't really want to make a new feature because every time you touched a piece of the code, it would affect 4 other places. Everything was highly coupled. It was hard to get velocity. Your test coverage might be iffy. You might have flaky tests, so it was hard to actually know if something was working the way you expected it to. There's all these hidden gotchas in your code where if you made one change, it had unknown circumstances in the other, and you were causing bugs for your users. You weren't getting your stuff out on time, and it just created this frustration that I really didn't like the work that I was doing. And yet, at home, I had this awesome experience, right? I could use Dart. It had batteries included. There was all these tools that I could leverage, and I could start doing awesome projects right away. It was like being on a rocket ship, right? It just made my experience so much better. I loved to code again. It was so night and day from what I was experiencing at work. And something had to give. Something had to change. So I went back to work, and I started analyzing the problem. I'm like, how in the world can I bring that experience that I had at home and bring it to work and make the environment better for my team, for myself, for perhaps others? How do we make this situation better? And looking at the problem, it seemed impossible. It seemed ominous. There's so many projects that would need to get updated. There's so many pieces that needed to change, stuff that was legacy and we wasn't quite sure how it worked, and we were afraid of updating it. It just seemed impossible. And I didn't work at an old world company. We didn't use a waterfall model. We didn't do our requirements out for a year or two before we even started a project. I worked at Google, a modern, fast, iterative company that built many of these tools that I was using at home. If I couldn't make my developer experience better at Google, where in the world could I, right? Did I need to go work for a startup? Did I need to switch teams? I chose to do the googly thing. I chose to try to make the environment better for myself, for my team, and maybe for more. Now, I'm not saying that I was like the one person that got everything started. That's not what it was entirely. I was a pebble along with Ferhat, myself, and many other teams at Google that were getting frustrated with the environment that we were using. And we started creating this avalanche, right? And it's just kind of swept us all up. You start seeing so many teams switch over to Dart and the environment that it provides. And it's really this great story between the Dart team, who really want to build these small to large, humongous apps that are performant, that are beautiful, that really help you code on the web, and these ad teams that have the exact same requirements, right? We don't want to have to worry about our frameworks. We don't want to have to worry about our language. We want to have to write our production code for the problem that we're trying to solve, which is allow advertisers to create their ads and really sell their product across the web. And in the process, it makes Google a little bit of money.
We basically had this inherent requirement of having the teams being productive and very productive. In Google Ads, we have many mission-critical apps, and they sort of they start out at a couple 100,000 lines. And we have systems that are in the millions of lines of code. And what makes it even harder is we have very large and distributed teams. So we have ads teams all over the world, in Europe, across many time zones. And basically, we had to get productivity up to a level where we could keep up with the changes in our business. Google Ads is evolving very fast. The requirements change. We literally every month, every quarter, we have to make changes in our application and add features to support our users, our business needs, and the needs that are changing so fast require teams to be very agile and be able to confidently make changes on very large code bases.
Yeah, and it wasn't like that, right? 2 years ago, it wasn't a good situation for us. Some of our projects could take 15 to 30 minutes before we could actually see a change on our local machine. And this doesn't create good practices. You start writing as much code as you can before you actually see if it starts working. It's really hard to make even simple CSS changes or see how your style flows. Even the simple things become really tough. And it had some other problems too. We were finding that the time that our UX people and our UI people were getting us mocks for us to implement, it was just taking way too long to get those mocks and actually get them into our production system. And it was creating unhappy users because we weren't giving them features that they wanted in a timely manner. It was causing unhappy managers because they weren't seeing progress. It was causing unhappy UX people because they were coming up with all these cool ideas, and we just had to push back on them because our systems really wouldn't allow us to make it work. So we started evaluating, like, how could we make this better? How could we make our environment this fast and productive experience for everyone, make our developers happy and make everybody else happy in the process? And Dart was really one of the answers that we liked a lot. We evaluated a lot of languages, but a secret is that all of them had types. We really didn't want to try to use a system within Google that didn't have types. We have a lot of help on our code. Even if you use VI or Emacs, we have tons of systems that can understand the semantics of our code and can help us to find bugs earlier, whether it be a linter or a test tool that actually can find them, or somewhere where you can just go into a web search of your code and you can figure out every instance of it. You can figure out patterns of how it's being used. You can click on the type and figure out where it's being used and who else might be implementing it or who's overriding it or whatever it might be. It makes it really easy to grok this huge code base that we have. You can go in and see, and we can use infrastructure across the whole system and really understand where it's being used within Google. Another feature that we really liked was Dart is as fast as JS, sometimes faster, right? And when the times where it's slower, it's only a little bit slower, right? It's very important for us to get very, very performant systems. We want 60 FPS. It's a challenge for us, but that's what we want. Even on our ad systems, we want it to be fast, beautiful, and vibrant, and have smooth animations. And we didn't have that. We weren't experiencing that at the time. We were pretty far away from the metal. It was hard for us to make changes. Our system before was trying to protect us against all the different browser languages, right? And we kind of grown past that. The browsers have gotten better. They were pretty much working on the same platform now. And there was all these things that made it really hard for us to dive into the internals of what was happening with our DOM, to make this really fast paint speed, and make our widgets beautiful and vibrant for our users. A hidden thing that we got, and you might not think that we needed at Google, was the package manager, right? And it's not really because we need to go download code from pub and use it in that way, but we got a lot of hidden benefits from using this common infrastructure within Google. Dart had batteries included. The libraries would work together. We didn't need to try to figure out which keyboard library we were going to use, which stream library we were going to use, what module loading library we were going to use. It was just there. It was inside Dart. And it gave us all these patterns that we could reuse over and over again. And all of a sudden, our code started looking really similar, right? You see the future pattern in a lot of our code. You see streams in a lot of our code. It's actually inspired other libraries. It's pretty cool. And it also allowed us to start using more external libraries that we found. We could bring in external libraries, and we could just start using them. And they worked within the ecosystem. We didn't have to worry about them conflicting with other libraries or not working in our framework or not having types so that we could easily understand what was going on. And a great story of this is we weren't really happy with the mocking story that Dart provided us. It uses string-based mocking. It wasn't really good to refactor it because you might refactor the method, but you didn't actually refactor the string that was trying to make sure that it matched. It didn't have autocomplete a lot of the times. We weren't in love with it. And we could have just went to the Dart team and said, you know, this isn't good enough for us. Please rewrite it all and give it to us, right? Spend some cycles and ignore all the cool other stuff that you're doing for us and everybody else, and please give us a better mocking library. But instead, we found an external one. We found Dart Mockito. And we could just use that. We could bring it into our system, and everything just worked. And there was nothing we had to do to make it so that we bring in the libraries or whatever. This ecosystem was just vibrant. We could start leveraging external, and we could start giving to the external community too. And this wasn't actually always true, but we actually used the pub system within Google also, right? And before, we actually had some of our own tools, and we were actually envious of you guys, the external developers, because you had pub serve, you had pub build, everything just worked for you, and there was no, wires or there wasn't like glue sticking everything together, right? And sometimes it worked and sometimes it didn't. And now we actually use pub build and we use pub serve, and it allows us to have that really fast refresh cycle to leverage all the tools that you get. We get to leverage that test runner that's coming that you guys saw, and it will just work for us. We don't really have to worry about building our own tools to do all that cool stuff. So really, this is a story of the synergy between the Dart team and us, of giving us the tools to become powerful and really worry about only the problems that we need to solve instead of trying to solve all these language and framework problems also.
So we wanted to share some of the experiences we've run in using Dart in our projects over the past couple of years, and also point to some of the strengths that helped us solve these issues. So one of the big items is always performance. When I joined the CRM project and we were just starting out, I had a meeting with a product manager, and he started demoing the existing application to me. And some of the views, some of the reports were so slow, like middle of the meeting, he just stopped demoing it. And he started talking about the future, what he'd like to see in the new system. So applications sort of never start slow, they start getting slower and slower as the application is growing. You're adding a lot more features, you're making changes, you're adding abstractions and more layers to your system, and sometimes it feels like there's this black hole in the browser, and all your CPU cycles are sort of disappearing into the black hole. And so one of the issues we ran into was when you closely monitor a production system, you sort of get your P50 numbers, 50th percentile performance, 90th percentile performance. And looking at enough systems and enough applications out there, you sort of have a good idea of what the ratios should be. So P50 to us is pretty much working in Mountain View with excellent networks, being close to our data centers. And P90, 95 is sort of, people are on slower connections. Maybe they're on older hardware. And the numbers sort of always reflect that, no matter which system you look at. If you look at Gmail, you look at Calendar, they're sort of constant factors. And in our system, after we started testing it, that was written in Dart, we basically saw that in P90s and 95 numbers, we had sort of a big drop-off in performance. For example, we had these giant tables with 20 columns and thousands of rows, and when you sorted the columns, it should be instant, right? And on P90th, we were seeing these really strange and big numbers that were beyond, we couldn't explain really with the hardware differences. So we turned our attention to memory, because the logs also showed some of these applications, they're mission critical. People sit down in the morning and use them all day long. A CRM app, they make calls, they log meetings, they look at sales pipelines all day long. And what we saw is on P90th and 95th, we saw very high memory usage. So we said, okay, maybe that could explain what's going on in performance. So we ran some numbers. We basically started stress testing the application and started running the browser slowly out of memory. So what happened was, as soon as we hit about 660, 670 megs of memory use, we saw a very sharp decline in performance. Essentially, the app would be 5 to 6 times slower under high memory pressure. And when you build a large app, and you've built thousands of lines of code and 300-400 libraries, it's sort of very hard to go back and find where the bottlenecks are. But with Dart, we had these wonderful tools. Observatory really helped us diagnose some of the issues, see where we had sort of services that were global. We were subscribing to streams and never releasing them. So, and as the user was going through their day, essentially we were holding on to memory. So tools like Observatory allowed us to automate a lot of this and make sure that going forward, we have both memory and performance under control. So yesterday you heard the protocol for Observatory is going to be published. And this will allow you to basically run your tests, go to a blank page, go to your view, go back to a blank page, and then talk to Observatory and say, do I have any controllers, any views, if you're using MVC, is still on the heap. So you can easily build these into your tests and make sure whenever people add features, and once you have hundreds of engineers adding features, you want to make sure that these problems don't get worse in your system as your application grows. So today, for a very large business application, we have very stable and low memory use using Dart. So typically, a P50th, we're in the 100, 150 range, and P90th, we're staying well under 300 megs. So the tools that Dart provided were really key for us to, not only in our daily workflow, to be able to just pull up Observatory and use it to make sure we didn't have any issues regarding references, strong references that we were holding on. But these tools also allow you to build them into your systems that monitor your code health. And another big requirement we have in ads is that we need to scale to very large teams. So when you put together a large number of applications in one big system, sometimes it feels like it looks like this. Essentially, the bits and pieces work together, but it's not exactly harmony. So with Dart, as Ted said, batteries are included. It shipped with wonderful libraries from day one. And the libraries are consistent across. So if a library had to use a certain pattern, it was iterables or streams, and it was consistently so. We didn't sort of have one library in the system calling it push or destroy, and another library calling it add and clear. It was these patterns that were nicely followed by not just the Dart team, but all of you out there publishing pub packages. The libraries look very similar and sort of work in harmony. I can easily read code from a team I had no contact with before. If they're using Dart, it just feels natural to reuse their libraries. And that sort of helped us become, although we have huge number of engineers, we became sort of a smaller team that reused more code. And some of the libraries we built, we were able to open source. For example, in the business app, we had needs for showing pipeline charts, but 50 of them on a screen for each customer. You would just see your sales pipeline. And we needed to do that in X milliseconds. So it was a good experience. So we took D3 and we did a port. It's called Charted. So you can find it on GitHub. It's basically a nice charting library. And we shared that with the Dart ecosystem. Some of our RPC libraries we were able to share. And a lot of the Dart sort of inspired all the teams to follow the same patterns. Our RPC backend, when we say, give me a customer record, we literally get a stream. We say, listen on the stream. Send a query, listen on the stream. And then whenever there's an update, our RPC layer just pushes it through a stream. So it allowed us to create much, much nicer libraries.
So like I was saying before, we had this problem of our apps were really large, but they were really highly connected, tightly coupled, right? And it was hard to even get our head around how we were going to start updating parts of it. Not all our teams had the luxury of a team like Ferhat to just do an RM-RF, like Dan said, and just start from scratch. We did actually have the requirement that we did have to build up some of the apps and slowly start iterating to get a better system. And so how we did this was we started modularizing our apps. So even though to the end user, it looks like one large app that they can use, internally, it's actually a couple smaller apps built together to become one coherent one. And this is very important to us because we can't allow the user to say, well, if you want to do search ads, you need to go to this application over here. If you want to do YouTube ads, well, you got to go to a different one, right? If you want to have display ads, well, that's another URL that you need to go hit. It was very important that we had one-stop shopping for our advertisers. But yet, we found that if we tried to do this all in one large app, our team's just velocity grounded to a halt. It was really hard to add more engineers on this humongous app and allow them to iterate quickly and start doing new stuff and to build out new features and really get the velocity that they crave and they desire. So how did we do this? Well, we started splitting them up, and yet we used this very simple pattern to make sure that they could still talk to each other. And why do we want to keep it simple? Well, we want one very simple interface because all these modules will need to talk to each other using it. And if it's complicated and we have to change it often, there's a chance that we're going to break it all the time, right? And we really don't want that to happen. So if we keep it simple and yet powerful, we don't have to change it too often, and yet everybody gets the power of it. This is actually just it turns out to be like 6 lines of JavaScript that allows us to talk between all these apps. And the cool thing about it is that we could have different technologies for each one of these apps. We could have an app written in Git. We could have an app written in JS. We could have an app written in Flex if we wanted to. We don't, but we could, right? As long as it talked JavaScript, we could actually have them talk in between each other. Yet, it was important for us to have this consistent API layer. We needed the data consistency always. You could imagine that if our data ever gets inconsistent, it is a nightmare to make sure that it's cleaned up at the end of the day. Migrations are a pain, and we do not like doing them. Also, if there's a bug in the system or you accidentally introduce some data that you shouldn't have, it's possible to cause millions and millions of dollars to be lost very easily, and it's very scary sometimes. So if we had this consistent API layer, we could make sure that the data was always saved in the same way. So all the apps, even though they were separate apps, were still talking to the backends in a consistent manner. So let me give you an example of this, and I'm actually going to do a live example. So this is AdWords. Many of you might not actually recognize it, but if you were an ad agency, it would be very familiar to you. And on the left and on the top, that's actually separate apps. And they're Git apps right now, and they're what we actually had before. But this app in the center right here is actually written in Dart. We could allow us to do business logic, hovers, all that good stuff. And it could interop between the two systems very easily. So it allowed us to iterate, our team to iterate and get some Dart app code out there without rewriting everything. Another benefit is these charts were pretty complicated. We didn't want to write them from scratch. So we could leverage the JS library that we had at Google to actually provide these charts for us, allowing us to not have to rewrite every library if we chose to. And it allowed us to keep the animations and all those cool things, but yet still have all of our business logic and all the other UI elements in Dart still. Now, the crazy part, if we want to go even deeper, is this app is now a Git app. So now we have a Git app inside of a Dart app, which is inside of a Git app. We got to go deeper, right? So it really allowed us to iterate and not replace everything if we chose to. Sometimes we could do what Ferhat's team did and just burn everything and start anew. But it also allowed us to iterate and make changes individually and allow teams that wanted to velocity without sacrificing all the hard work and app that they had currently. So the strategy for this is really divide and conquer. Even if you could start over, it's still a good idea to keep your app modularized and allow, you hope that your app can scale from a team that's 2 or 3 people to hundreds and hundreds, right? And if you kind of keep them modularized, you can do that. You can keep the problem smaller and allow them to think about it.
So finally, before Kevin throws me off the stage, we're a little over time. So we ended up with a wonderful system. So in 6 months, we built the app, shipped the first version, and CSAT scores more than doubled. And we had a really happy team. So the developers were happy, the users were happy, and some of the experiences we had, they were so successful, ads decided basically to invest heavily in Dart. And many of the teams are now coming online, and they're starting to build their apps in Dart. We'd be happy to talk to you afterwards, and thank you.